And Preston is here also. He's
Preston's here.
Yep.
All right. Good morning, guys. Welcome to office hours, where we get all the assignments completed before everybody else. Isn't that the best?
Yes, it
All
is the
right.
best.
So we are on the next exercise. I hope everyone got a chance to take notes on these two videos. Okay. Remember, when you watch these two videos, take notes on it and then submit it in the correct corresponding places, okay, in Google Classroom. All right, so we are up to the next exercise, and the next exercise is this thing. Let me see here. So we talked about area. Actually, no, we're up to this right now. Area of a sector, okay? That's what we're going to be talking about today. And I will give you some notes, okay, that directly relates to this, okay? So before we get to the assignments, okay, I'm going to give you some notes on that first. And oh, and if you don't have the Khan Academy opened up right yet, okay, please have that tab open, and let's get to the correct place. We need to hit next, I think like 15 times before you get there. So let's do this. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. And here we're going to see, actually, no, I think we may need to hit, yeah, we'll need to hit next one additional time. So it's 16 times.
Yep, I see it right there.
You see it, Chris?
Yes, I do.
Okay. Area of a sector. Okay, so we're not. I'm gonna open that up. Okay, but we're not gonna get to this right yet. Okay, instead, I'm gonna show you some notes, and then from there, we'll figure this out. Okay, so you can solve this certainly by using a little bit of logic, but I want to also show you there's a really neat formula that you can use, and it will be applicable when we get into things that are slightly more complex, especially, okay, when you guys are moving into like Algebra 2 next year, okay, where things are going to get even more abstract, okay? So it is important for you to be aware of certain formulas. So I'm going to get over here on my tablet, and I'm going to jump on to this video call, and I'm going to stream my tablet so that I can write and explain to you guys. A second here while I get connected.
I gotta go to the bathroom.
Go ahead.
Okay.
Okay, here I am. All right. So what I want to show you is this concept here. So this was what we had talked about yesterday. We talked about radian measures, and we talked about how useful, right? Thinking about what a radian measure is, and then how we can find arc length. The formula for finding arc length, when expressed in radians, is way simpler, okay, than the formula involving arc length related to degrees. So let's take a look at the next topic here, which is this idea of a sector, okay? So what exactly is a sector of a circle? A sector of a circle is simply this idea, and it's really, it's nothing that abstract, okay? So if I have a 2 radii, okay, and I have an angle theta here, like so, okay? This slice of the circle is what we call a sector. This is a sector, okay? So this is the slice of the circle. It's the area that is the area of the slice. And I'm putting the word slice in quotation marks here because slice is not a mathematical term, okay? So whenever a person thinks of a circle, you know, certain foods come to mind, like a slice of pie, a slice of pizza, okay? So that's why I'm using the word slice there. So area of the slice of the circle. So that's what a sector, that's what the sector of a circle is, okay? And our goal, okay, is to come up with a formula, okay, that we can use to find the area of the sector here, okay? So what I'm going to do, okay, is we're going to fall on the things that we're familiar with. Is this a true statement, boys? And again, I'm going to box this in because this is the main idea here. Is the following statement true? Okay, is the area of that shaded region there proportional to theta over 360? Again, is the area of the shaded region there, like the area of the shaded region to the area of the entire circle, is that proportional to theta over 360?
Yes.
It is, right? So again, the logic one more time. Theta to 360 should be proportional to the area of the sector to the area of the circle. So that's the main idea here, okay? From that proportion, we will then be able to come up with a formula that describes the area of that sector. Everyone here follow logic right now? Okay, so what we're going to do, okay, we recognize the following, okay, that the area of the circle, okay, has a formula. What's that formula? What's the area of the circle again?
Pi r squared.
Pi r squared. Thank you. So the area of a circle is pi r squared, okay? And then the sector, I want to give a letter, okay? I'm going to use the letter A, okay, to represent the area of the sector, okay? So the area of a sector, okay, over the area of the circle should be proportional to theta over 360. So that's what I'm going to do. I'm going to try to isolate A because that's the whole objective here. We're trying to figure things out about the sector, this idea of a sector. So this is, again, pi r squared theta over 360. Okay? So that's what we have at the moment. And wait a minute. Area, okay, is equal to pi r squared theta over 360. If I manipulate this a little bit, okay, I'm going to try to manipulate this. Isn't this the same thing as theta pi? Whoops. Isn't this the same thing as theta pi over 360 times r squared? Is that the same thing?
Yeah.
Yeah, I just manipulated, I just rearranged some things, right? Now, a lot of times, okay, in mathematics, okay, as well as in science, and basically anything that's like logical, okay, as you're moving through the world, you want to look for things that are in common. You want to look for commonalities, okay? And immediately, okay, I notice that this factor here looks pretty familiar, okay? We've seen this factor repeat itself over and over and over again, okay? And it doesn't quite look like that. And I'm going to manipulate this a little more. so that it becomes even more recognizable. Is this transition true? Did I make any crazy like move here? I didn't,
No.
right? Can
No.
everyone see the last thing I wrote and the second to last thing I wrote, that they were the same things?
Yes.
Yeah, they're the same things. Okay, so one more time. What's this? Where have we seen that before?
That's the original equation. That's like equation for degrees.
That's the conversion. One more time.
The conversion equation for degree measures.
No, it's the conversion
From degrees
from
to radians.
Radians to degrees.
the other way around.
No, degrees to radians.
Degrees to radians.
Conversion from degrees to radians. Okay, and again, it is the conversion from degrees to radians. Okay, so wait a minute. So this thing that's highlighted right now, okay, if I know something that is in degrees, okay, and I throw it in there, okay, this whole thing, the thing that's highlighted right now is really, is that a degree measure or is that a radian measure?
Radian measure.
Again, the thing that's highlighted right now, is that a degree measure or is that a radian measure?
Radian measure.
That is a radian measure. And yesterday I gave a radian measure a Greek symbol yesterday, right? What Greek symbol did I use?
Beta.
I used beta, right? Okay, but understand this. Beta and theta, okay, they represent the same things, okay? It's just that one is in radian and the other is in degrees. Okay, so now I'm going to rewrite this. This is the same thing as 1/2 beta times r squared. And again, understand one more. This is really important. This is crucial to your understanding here. Okay, is beta, the thing I'm highlighting here, is that the same thing as the stuff that's highlighted in pink?
Yes.
Yeah.
They are the
different
same
things.
things. Do they represent the same things?
Yes.
Yes.
They represent the same things. The difference is beta is in radians and theta is in what units one more time?
Degrees.
Degrees. That's all it is, okay? So this formula right now, okay, this is the area of a sector of a circle. So this guy, right, I'm going to write this over here. This is the area. Whoops. For the sector.
And it's the same thing if the measurement that they give us has theta or is a degree measure, then we use the first one. And if it's a radian measure as beta, we use the second one.
That's right. Okay, so, and I'm going to make a drawing here, okay? Whoops. And you guys should also make this drawing yourself as well, okay, so that you're not just watching this, okay? You know, it's like watching this stuff on YouTube or watching YouTube videos. It's quite, you know, things can be educational and all, but there's nothing compared to like you rolling up your sleeve and actually writing this stuff down and thinking about it as it is being explained, right? Just because you know, writing does promote logical thinking. So again, why am I drawing two circles here? Again, I'm trying to emphasize that these two formulas represent the same things. Theta, okay, is in degrees. And here, beta is in radians. But in fact, they mean the same exact things. These two circles are describing the same things. The area of the circle here, they're describing the same things. Or area of the sector, rather. Okay? And I'm highlighting this in pink, and I'm highlighting this in green. Okay? Again, they mean the same exact things here, guys. Okay? So if I were you, I would just take a moment and write this stuff down, okay? Because we are going to use this in like a minute. Take a screenshot of that, write it down, okay? Doesn't that look like a Pokemon doll or ball?
Yeah, you're right. It does. Now that you mention it.
All right, do we have this, or do we? Do you guys need another 30 seconds?
I have it.
Everybody else? Is that a yes?
Yep.
Okay. So, with that said, okay, we're going to take a look at some of those exercises. I want to stop presenting over here. And I want to jump back in over here.
Mr. Chan,
Yeah, what's up?
can you keep that thing for one more second? I meant to screenshot it.
No problem. So I want to jump back over here.
And I accidentally, instead of pressing Command Shift 4, I pressed Command Shift, or no, I just pressed Command R, and then I reloaded the thing and kicked me out.
No problem. Let me see.
Thanks, Mr. Chan.
No problem. No problem. Okay, so I'm going to stop presenting here. Did you get that? Or I'm sorry.
Yeah, I got it. I got it.
Okay. So and
Just
then
in time, just
I am going to go over here, and we're going to jump right in now. Okay, so we're going to try to figure this out. Okay, so what does it say on this? It says now I have a I have a circle with radius of 3. Has a sector with a central angle of 60 degrees. What is the area of the sector? So this is the same thing like what we just talked about. So I have 60 degrees and the radius is 3. I want to jump back over here now. And present over here on my tablet. So I'm dealing with a circle with 60 degrees, and the radius is 3. Which formula am I going to use, the first or the second, guys?
the first.
I'm going to use the first one. So maybe Kian, can you help me with the substitution?
I can try.
Okay.
So, oh crap, I already forgot.
No problem. So it's here again.
Okay. All right. So it's the first one. So it'll be 1/2, and then multiplying that in parentheses for the numerator. It's 60 times pi over 180, and r in this case will be 3, so it'll be 3 squared.
Good. And then we're going to reduce this, okay? 60 goes into 180 how many times, guys?
3.
3, so it's pi over 3. And wait a minute. I have 3 squared and 3. Can one of them be eliminated?
3 squared, 9.
3 squared is 9. 3 goes into 9 how many times?
3.
3. So I'm left with 3 pi here. I'm left with 3 pi over 2. Okay? I'm left with 3 pi over 2.
So that's the
That's
answer.
my answer there. Okay.
So that's the
All right.
answer,
So I'm
Mr.
gonna
Chan?
jump back over here. What was that, Michael?
So that's the answer? 3 pi over 2?
You tell me. Is that the end?
Yeah.
That is the end. Okay. So I'm going to stop presenting over here. I'm going to pop in back over here. And we're going to enter in 3 pi over 2.
Got it.
Okay. All right. Question. It's asking. It's stating that a circle has a sector with an area of 33 pi and a central angle of 11/6 pi radians. Okay. So now you're told that you have the area and you're told what the central angle is, but this time the central angle is in radians. So I'm going to go back over here to my tablet and I'm going to draw this, and you should too, so that you can analyze this on a sheet of paper and you're not just watching, right? So you should write some of this information down as I am doing that right now, okay, on my tablet. The area is 33 pi,
Mr. Chan.
and the angle is 11 pi over 6. Okay.
You're not presenting anything.
And you're asked to find out what is the you're asked to find out what is the area of the circle there. Okay. What is the area of the circle? All right, so I'm going to go back to the tablet. So guys, we're asked to find out what is the area of the circle, right?
Mm-hmm.
If you're asked to find the area of the circle, okay, what is the one thing that you have to have?
The radius.
You have to have the radius. So that's our pursuit, okay, in the next couple minutes. That's the game plan. We got to find out what the radius is, okay, and then hopefully then we can then figure out what the area is, okay. All right. So in order for us to go through this, okay, notice right now, okay, this guy right here, is that in radians or degrees?
Radians.
That is radians, okay. So because it's in radians, I'm going to use that second formula that I gave you guys today. 1/2 beta times r squared. So how are we going to do that? So I know that, again, area is equal to 1/2 beta times r squared. What am I going to replace a with? Maybe Chris, can you tell us?
What are we going to replace a with?
Yeah.
33 pi.
There you go. Michael, what are we going to replace beta with?
What are we going to replace beta with? 11 pi over 6.
And we're going to figure out what r is, okay, from this, okay? And that is the only unknown that we have in this equation at the moment. So if I do this, let's just get rid of that parentheses there. So if I get rid of the parentheses, that means I'm going to need to multiply the 1/2 with the 11 pi over 6. So when you're multiplying fractions, okay, do we cross multiply or do we multiply numerator with numerator and denominator with denominator?
Cross multiply since there's 11 pi.
You multiply numerator with numerator and denominator with denominator. I hope that's what you meant. Okay.
No, I said cross
So
multiply.
we're multiplying all the numerators together and all the denominators together, and we end up with 11 pi over 12 times r squared is equal to 33 pi. All right, so at this point, okay, we're going to need to divide both sides by 11 pi 12ths. And this looks really scary, doesn't it?
Yeah, it does.
Right? But don't be afraid. Mr. Chan is here. Right? That's what you're doing, aren't you? I'm dividing both sides by that fraction. And when you're dividing both sides by that fraction, what happens to the fractions on the right-hand side? What will happen to the fractions on the right-hand side? What will happen to this and this?
Cancel out.
They multiply the
They
inverse.
cancel out. We're left with r squared on the
it'll
right-hand
disappear.
side. And you're looking at me like I'm crazy because we have this like 33 pi and 11 pi over 12 here on the left-hand side, right? And it looks really disgusting. And I agree with you. It does look disgusting. But you know what? How do we divide fractions again?
By multiplying.
You multiply by what?
Reciprocal.
Well, that you
The
do the inverse
reciprocal.
of the second fraction is the inverse of the first.
The
It's like the
reciprocal
inverse
of what? The top or the bottom part?
the bottom part.
The bottom part there. So
Yes.
if this become, and again, I don't flip the top part. It is still 33 pi, right? But I want to multiply that with flipping of the bottom, right? So this becomes 12 over 11 pi.
So then it goes 1. So 36 pi.
So then actually it's not 36 pi because
We're not
pi,
in-
what happens to
Yeah.
them? I have pi in the numerator and pi in the denominator.
So so it's just 36.
Right. R squared becomes 36, right? So because look, pi's here cancel, 33 and 11 cancels to become 3. I'm left with 36 is equal to r squared.
And then
R
that's
squared is equal to 36, or r is simply what again?
6.
R6. But you know what? My goal, one more time, was to figure out, what this is, right? Area of a circle. If I know r squared is 36, what's pi r squared going to give me?
36 pi.
The area of this circle here is, the area of the circle as a result is 36 pi. Because it's pi times r squared, right? That's the answer right there.
Done.
Okay.
6 is R.
All right. So I'm going to flip over here, and I want to type in 36 pi.
Why do they give us the same problem again?
Because this is a computer program, and the computer program doesn't think.
36 pi, right?
Yes.
Yep.
But doesn't it know when it's the same problem?
I don't think that this Khan Academy website is programmed to recognize that these numbers are in fact the same. I may be
Or
wrong.
why would they have multiple problems that are so similar to each other in the system?
I don't know. Okay, so it says here a circle with area 9 pi has a sector with a central angle of 60 degrees. Okay, a circle with an area of 9 pi. Okay, has a sector with a central angle 60 degrees. What is the area of the sector? So this is essentially the same problem like Emmett's been saying. Okay. But with a slight twist, okay? This time, you're asked to find out what is the sector and not the area of the circle. Do you see the subtle difference there, guys?
No,
Yeah, I see it.
we were asked to find the sector last time too.
You were asked to find what?
the sector last time too. It's the same exact problem.
No, the last problem that we did
No,
not
two
find the area of
problems
the sector.
ago.
We found the area of the circle.
No,
of the
I meant
overall.
2 problems ago. It's like it's identical to one 2 problems ago.
You're right. Okay. So now that we know this, okay, the area is 9 pi. The central angle is 60 degrees. So we can actually think about this logically, okay, and not just like fall blind to a recipe, right, to a formula. So what fraction of the entire circle is that sector going to be? If the central angle is 60 degrees, what fraction of the entire circle is that sector supposed to be, guys?
1/6.
1/6.
1/6. That's it. It's 1/6. So, and if the area of the entire circle is 9 pi, right? All we got to do is multiply 9 pi by how much?
60.
No. What fraction of the entire circle is that sector supposed to be?
36 pi.
No.
5/6.
1/6. So the area of the circle, or actually the area of the sector, will be 1/6 of the entire circle. So 9 pi over 6, in other words. 9 pi over 6. That's it.
Got it. Now on to the last problem.
Okay, very similar. So a circle with a radius of 3 has a sector with a central angle of 1/9 pi radians. Okay? A circle with a radius of 3 has a central angle of 1/9 pi. Again, should we be using the first formula or the second formula that I gave you today?
Second.
The second formula. Nice job, Kelvin. So we're going to be throwing into that formula there. I'm going to switch over to my tablet. Okay. I'm going to switch over to my tablet. The formula, one more time, goes like this. It's area is equal to 1/2 beta times r squared, right? And we're trying to find the area of the sector here. Hey, Kelvin, what is the measure of the central angle again?
Beta.
It is beta. What is the measure of the central angle in the problem? What does it say?
Wait, can you go back to the problem?
What is a measure of the central angle?
1/9.
1/9 pi, right?
Yeah.
So I'm going to go back over here. So I'm going to throw in there 1/9 pi. And, Michael, what is the length of the radius?
3.
So 3 squared. So that's pretty much it. So area is equal to, and all I got to do is just figure out what this is. So 3 squared. What is 3 squared, Mike?
9.
9 goes into 9 how many times there?
1.
So I'm left with pi over 2. Because the 9 and 9 cancels, right? So that's the answer right there. It's pi over 2. And I'm going to jump back over here now.
Got it. All done, Mr. Chan. All done.
So remember, guys, we still have, or you still have, those notes that you guys have to take, right? So don't forget to do that. And if I were you guys, just try to get that done sooner rather than later, because we've gone through all the notes related to the area of a sector. Watching those videos again and just hearing it from another person, okay, can reinforce that understanding. So get that done. Get that done soon, okay? All right, I'm going to stop recording.